All right, let's look at this problem. Rotate the curve y equals ln x from 1 to e squared around the x-axis and find the surface area. Set it up with respect to both x and y and evaluate whichever integral looks easier. All right, so first up, let's graph this. If we look at this on here, to put in ln x, I have to call it log. For whatever reason, this uses log to mean the natural log. So anyway, we're going from there to, we're going from 1 to e squared, and e squared is there. So if I take this and I rotate it around the x-axis, is that what it said? Yeah, rotate around the x-axis. So when we do that, we get this. Let me put a few more, let me up my n here so that we can see something a little better. Yeah, so again, it's sort of the surface area of like a bullet or blimp shape or something. So we're going to find that surface area, and then we're going to, we're going to set up an integral and find it. So let's put that away, and let's do this. So let's do it with respect to x and with respect to y. So let's do x first. So if we do it with respect to x, we've got y equals ln x, y prime, or dy dx, as we're calling it now, is 1 over x. So our ds in this case is going to be square root of 1 plus 1 over x squared dx. All right, my drawing, I didn't draw it, but so we've basically got this sort of bullet shape. And our radius, the radius of this thing is going to be y. So the radius is y, which is of course ln x. So our surface area is going to be 2 pi integral of radius times ds. And we're going from the starting x value to the ending x value. So that's from 1 to e squared. All right, so that's one of our answers. Now, we also need to set it up with respect to y. All right, if we take y equals ln x, if we want to solve that for x, we need to do e raised to both sides. So we'll get e to the y equals e to the ln x. So x equals e to the y. And I'm going to write that just in the other direction. X equals e to the y. And now let's take the derivative. The derivative dx dy is going to be e to the y. And so when we square that, if you square e to the y, you get e to the 2y. So my ds here is going to be square root of 1 plus e to the 2y dy. My radius, as before, is y. And in this case, we don't have to replace that with anything. The radius is just y. So the surface area is 2 pi integral y times square root of 1 plus e to the 2y dy. And what are the endpoints here? The endpoints on this one are, let's see, the y-coordinate here to the y-coordinate there. Y-coordinate here is obviously 0. What about the y-coordinate on the other end? Well, let's see, this is the point, let's see, its x-coordinate is e squared, its y-coordinate is ln of e squared, and ln of e squared is 2. So we get that. So now we have to look at both of these and see which one looks better to integrate. That is in fact a trick question. Neither one of these are pleasant to integrate. I'm not really sure how we'd go about doing either one of them. So I'll tell you what, let's do. Let's use Desmos to get an approximation and just compare the two integrals. That's another thing. A really good thing about these problems is you can work them out two different ways and check your answer. So let's work both of these integrals out. Let's see. For starters, I'll do the one that I can see. Oh, I thought I could move that over, but I guess I can't. I can move this one. So if we put this integral in, we get 2 pi integral from 1 to e squared ln x times square root of 1 plus 1 over x squared dx. And for some reason it doesn't like that. Let me go back and maybe I need to put a times here. Okay, it doesn't like that. Maybe I need to put some parentheses around the x. Okay, yeah, 54.502. All right, now let's put the other one in. Let me get it up here on screen where we can see it. All right, 2 pi times the integral from 0 to 2 of y times the square root of 1 plus e to the 2y dy, and we get 54.502. It's always a sense of relief when you do both these integrals on a problem like this, and they both wind up being the same thing. So yeah, neither one of those is an integral I would say to try without just using a computer, because I'm not sure what technique we would use. All right, so anyway, that's it for this video.